time is a tricky concept to grasp. It's something we can't really see, but we all know that it moves. We know that it takes about 24 hours for an Earth to orbit the Sun, and about 23 hours, 57 minutes for a day to pass by. If time would move at a faster rate, what would happen? One of the major changes would be that days wouldn't last as long as. The Earth's geography and climate would change significantly when the Sun's activity increases. But at what point in time will life on Earth cease to exist? These are questions that the scientists are asking in order to understand the possible impact of global warming on Earth. We will explore these questions in depth. The Earth is not moving at the same speed everywhere. On average, it rotates once in 23 hours and 56 minutes. This means that the point in space where we're standing is experiencing one day every 23 hours and 56 minutes. Rotational speeds vary depending on the distance from the poles. Those who are closer to the North or South Pole will spin a little slower than a person at the equator, whereas those who are at the equator will spin a little faster. This is the Earth's polar axis. From this point, the Earth rotates around its axis in a counterclockwise direction, seen from above. This creates day and night. The North Pole is on the top of the globe, and the South Pole is on its bottom. The diurnal cycle is what makes our planet habitable. If we didn't have a day and night, the Earth would become too hot and potentially uninhabitable. The Earth's rotation on its axis gives us one day every 24 hours. The Earth's rotation is a driving force behind weather patterns. The rotation of the Earth causes ocean tides, which are affected by this rotation. However, if we were to accelerate the Earth's rotation, would that have a destabilizing effect on the climate? If the rotational speed of the Earth increased by just 0.45 meters per second, our days would be slightly shorter. On average, this would mean that if you noticed this, you might not even notice the change in your daily life. Though this slight increase in speed may yield a minimal amount of sea level rise, it is important to note that the effects of climate change would only continue to be felt for further generations. The water surrounding the poles would migrate toward the equator because of the change in temperature around them. As ice melts, it becomes water and is pushed by natural pressure towards warmer areas. What this means is that as Earth continues to warm, ice will decrease further and sea levels could rise up to 2 meters by 2100. Increasing acceleration to 100 miles per hour causes a noticeable effect known as jet lag. This is because of the 24-hour cycle most people are used to. A person who starts working at one end of the day with an acceleration of 100 miles per hour would feel confused by starting work at two different times during the day, causing exhaustion. When they finish their day, they would then be back on Earth time. With this in mind, we can see that. But for sea levels, it would be a dramatic change. The world's oceans at the equator would rise as much as 30 to 65 feet. Places like New York City, Venice, and Mumbai would be submerged. Millions of people would be displaced. If we doubled the current rotation speed of 2,100 miles per hour, disaster would strike. In fact, water would cover everything except for the highest mountains, such as Kilimanjaro or the highest summits of the Andes. Fortunately, this is not a significant concern because these two mountains are so high that they would remain above water. If satellites orbiting the Earth were out of sync with the rotation of the planet, they would have created disruptions in communication, TV broadcasting, and military operations. You would notice some significant weather changes. The air would be heavy with moisture and would also have dense fog, clouds, and constant rain. This is due to the equatorial regions being near the equator. If you keep constantly speeding things up, at some point you could fly off the planet. This is because the centrifugal force of the rotation would be enough to overcome the gravity keeping you on the surface. At a speed of 17,641 miles per hour, this would happen. you would experience reverse rain. Droplets of water would move upward in the atmosphere instead of falling because of the angle at which the water was dropped. If we were to push the speed up to over 24,000 miles per hour and let it go at that speed for a very long time, the Earth's crust would begin to flatten at the poles and bulge around the equator. This would cause earthquakes on a magnitude that is much larger than anything we have experienced in recent history. As the speed of light increases, the chances of something surviving on Earth become slimmer and slimmer. If a small percentage of that speed were to be multiplied by a few trillion, things might get really bad. If the Earth rotated at a speed of 186,282 miles per second, that would be 652,000 times faster than it does now. The dimensional contours of the planet would change as a result of the effects of the once spherical Earth, which would come into contact with its own orbital force. In turn, you and every other object on Earth would be subjected to a drastic change as well. What began as a spherical shape some 500 million years ago would become a flat disc-like shape with all objects having been compressed into one form. Rotating at this extreme speed would distort time on Earth. It would slow down so much that it would eventually stop. You would freeze in time. So hopefully, you would be caught in a good moment, and the distortions wouldn't become too severe for you to continue rotating. Black holes are incredibly powerful gravitational forces. They can suck in anything in their path, including light. The Earth, which is currently the size of a basketball, will become a black hole in the near future. At the speed of light, your car would be pulled in before you could blink. If you happen to be outside when this happens, then you would actually see it happen, because it takes less than a fraction of a second.